right, so coming in out of the cold here, get the hat off. There we go, and knock it down. I still got a little hair left. Not much longer, but that's okay. We don't care about that. Let's look at basic 8. Again, this is just to make sure that everybody's learning something. So let's look at our first problem will be f prime of x is equal to 3x times parentheses 2x plus 3 to the 7th. And we're going to find f double prime of x, which is basically saying the rate at which this function is changing. So notation, right? First derivative, second derivative. So we're going to take the derivative of that. Hopefully you see the product and chain rule. So we'll do the derivative of the first, which is 3 times 2x plus 3 to the 7th plus 3x. I'm changing the way I do this actually. Leave the first one alone. Take the derivative of 2x plus 3 to the 7th. So we got to do the chain rule. So what's the best way? I guess we'll put it in parentheses. So parentheses 7 times 2x plus 3 to the 6th times the derivative of what's inside the parentheses, which is 2. Okay? And then you can always doctor it up if it's a multiple choice test. All righty, so that's problem number 1. That's pretty standard. Product rule, chain rule, just mechanics. Hopefully folks have got that down. Then writing the equation of a tangent to a trig function. It's not the calculus that's bothering people, it's the pre-calc. So y will actually do it in algebra 2. So y equals the sine function. And we're going to look at 4 pi over 3. All right. It's good to always have a picture. So sine function, altitudes in the first 180 are positive, and then they're negative. And 4 pi over 3 is in quadrant 2. It's right about, quadrant 3. It's right about there. Right? This is the first 90, that's the second, that's the third, and then the fourth. So we're looking at rate of change at that instant, as is indicated by the slope of the tangent line, which means that at 4 pi over 3, in a moment, we're going to see that that's negative root 3 over 2. Now, if we're going to approximate that, negative 0.87-ish, and then we're going to look at 4 pi over 3 plus 0.0001, and we're going to look at that second y value, and we're going to get a feeling for the rate of change in y compared to the rate of change in x. And we can see that it's, looks like it's about minus 1/2. Let's find out. So sine function, top half broken up into 3 parts. 1, good drawings get good answers. We're at the 4th. There we go. So yeah, that's negative root 3 over 2. And this is negative 1/2. Oh, I guess that line is negative 1/2. Slope of sine is cosine, unit circle. All right, so minus 1/2, x minus 4 pi over 3, minus root 3 over 2. And I think for basic 8, we're going to do this every single day until the end of the term. Okay, we're going to learn our unit circle that way. So for those of you who didn't last term, and I can see that many of you didn't, hopefully you'll catch on in the next month. All right, so that's going to be part of basic 8, a sine function tangent line every single night for the rest of the term. All right, so that's the second one. Third one, straight product, straight chain rule problem. So let's say y equals 3 tan 4 minus x over 5. All right, so we're just going to take the derivative of that and apply the chain rule to it. This is one of those f of g of h of x problems. So we're going to take the derivative of that, which is f prime of g of h of x, g prime of h of x, h prime of x. And then the last one is derivative of what's inside, which is 1 in that case. All right, so y prime, derivative of something to the 4th. So 4 times 3 gets us 12. I might as well say that. 12 tan to the 3rd minus x 5. Then we're going to take the root of tan, which is secant squared with respect to where you are when you put an x in. You got a little calculation there. So on the graph of the secant, Got to find that before we square it. And then the derivative of what's in the parentheses, which is -1/5. That had given us a lot of trouble on the midterm. And I think I didn't write it -x. I just left it as -x. People didn't see the -1. Okay, so there's a little practice with that. If you've been getting that wrong, hopefully you'll get it right the next time. And then we got the integral 5 over x squared dx. Got it wrong. I hope you get it right the next time. I hope you write 5 times the integral of x to the -2 dx. Right? It doesn't matter if you leave the 5 in or pull it out. So that's 5 times x to the -2 plus 1 over -2 plus 1 plus c. That's what you got to doctor up. So that becomes -5/2. No, sorry. -2 plus 1 is -1. So just -5. Guess I'll put it a little lower. -5x to the -1. And you can write that as -5 over x plus c if you want. Your choice. Okay? Either one's acceptable. Plus c on this side as well, right? All right, so that's that problem. And then we're going to do a little bit of a 1 to 8, actual definite integral. Definite integral is an actual number. 1 to 8, cube root of x dx. All right, you're pausing the video. Hopefully we're in that routine, so I don't have to say it anymore. Just perfunctory, pause the video, do the problem, see if you get it right. All right, so that's the same thing as x to the 1/3. Now we do the same thing, x to the 1/3 plus 3/3. Well, that's 4/3 divided by 4/3, 3/4. I hope everybody's got that shortcut down. And we're going to now actually throw some numbers in, a 1 and an 8. All right, so we got 3/4 parentheses, 3/4 x to the, 8 to the 4/3. We're going to throw the number in, 8 to the 4/3 minus 3/4, 1 to the 4/3. Well, that's not a problem. That's minus 3/4. Hoping that people have finally figured out that you take the cube root first. 2, 16 divided by 4 is 4. I think this is about the 4th time we've done the same problem. So this is equal to 11 and 3/4. I'm sorry, 11 and 1/4. Or 4 times 12, 48 minus 3, 45/4. I prefer this myself, but acceptable answers either way. All right, so we've got a few more problems coming our way. Let's try to figure out the mean value theorem for derivatives for the function. What did I pick? Oh no, I'm just going to do average value. No, we're going to do that in class. Oh, let's just pick something. So let's do x cubed. Average value, mean value theorem for derivatives, mean value theorem for derivatives over the interval -3 to 5. All right, -3 to 5. So we got something that looks like this. -3 gets us -27. 5 gets us 125. And we want to find, looks like there's 2 places. Looks like there's one there. It looks like there's one in here where you're going up at the same rate, right? Parallel rates. Okay, so that's what we're going to find. We already have some of the information necessary. So how do you get from -27 to 125? I think you go up 152. If I make a math error, you correct me later. Looks like you're changing by 8. I hope that goes in nicely. But if it doesn't, it doesn't matter. So we got, no, just once. 172, 19. Very nice. Okay, so it looks like it goes 19 times. So this is a over 1 up 19 ratio. So if I went over 2 units, I'd go up 38. Right? That maintains itself. That's the average rate of change. And we want the average rate of change to equal a momentary rate of change, which is all about derivatives. And so we're looking at 3x squared. Okay, so you got plus or minus the square root of 19 over 3. All right? Divide square root. It may seem simple, but some of you are still doing the algebra 1 method that somebody drilled into you, and I wish you'd stop. Right? I know people got drilled into 2x plus 3 equals, I don't know, 21. Oh, subtract 3. Subtract 3. Whoa, 2x equals 18. Divide by 2. Divide by 2 equals 9. Okay? If that applies to you, I'd like to see you not do it that way. And I'll tell you why. Because there's three things you do in math. You evaluate, you solve, and you graph. Solving is all about inverse operations. And when you start thinking about inverse operations, you actually start to develop I think, a thought process that is extremely beneficial going up the ladder in this discipline. And I know when I broke the habit of what people taught me to do in Algebra 1 and made me do and showing all work, that is when I started thinking differently in this discipline. So something as simple as 5 minus 2 equals maybe written as 3. Then 5 is equal to 3 plus 2. It sounds simple, and it is. Subtraction becomes addition. It's not so much the numbers, it's about the operations, right? And that maintains itself throughout everything we do in math. Division becomes multiplication. Squaring becomes square rooting. E to the x becomes ln of x. Arc sine becomes sine of. Okay, and that is hugely important as a thought process. All right, so watch and perhaps adopt that, and maybe you'll have the same experience I had. What are we doing next? We are doing, see if you can recognize the answer to this question. There's a limit. Okay, pause the video. All right, so what's it saying? It's saying that, oh, well, I know what 3.14 is. 3.14 is this place on the circle right there, right? And 3 is just a little bit above it. 3 is a little bit above it. What we're actually doing is we're looking in a table where we're going to go from 3 for the sine function to 3.01. This is the sine of 3. This is the sine of 3.01. We don't ever want to have to write that again. We want to look at x minus 3, which is a change in x. What kind of change in x is it when you go to 3.001? A dx. Okay, so that should be enough to say, okay, well, this is the corresponding change in y. We're looking at the derivative of the sine function at 3. The answer is cosine of 3. Okay, so here's your sine function. We're looking at the rate of change right there, which is negative. Here's your cosine function. 3 on the cosine function is right there. Looks like we're going down nearly at 1 to 1. That's a slope very close to minus 1 to 1. It's actually minus 1 to 1 at pi. That's what's going on with that calculation. All right. All righty, let's see what we have left. Oh yeah, differential equation. So we have dy dx equals 4x minus 10. And we now know that y of 0 is equal to 7. Okay, so it would be nice if we could say what y is. That's the derivative. It must have come from 2x squared minus 10x plus c. And if I plug in a 0, that part of the polynomial becomes 0. So I guess c is 7. And we have solved what's called a differential equation. Okay, I'm hoping to see all of those problems right on the next test. That would be nice. That means you learned something. Anything else over here that I haven't covered? I think we're fine. I think I did all the ones I wanted to do. So I'll stop this at this point and upload it for your homework for, I don't know if it's tonight or tomorrow.